Master in Anatomy and Physiology with Indramani Pandey.
Hello guys, welcome to my another lecture about connective tissue proper, right? In last lecture we talked about in the same topic but we covered dense connective tissue. Okay, we talked about regular, irregular and elastic on that topic. But in today's topic what we're just going to do is I'm going to just like introduce you to the cartilage. What are the main characteristics of cartilage? What are the terms associated with cartilage? And I'll give you some take home information that you can utilize to get more knowledge about cartilage. Okay, and before I dive into today's topic, the cartilage term itself is very unique. Okay, and it is very important for us to understand the structure and function of cartilage to understand its overall function. Okay, so let's get started. Let me go to the another slide. Okay, here you go. As you can see here, there are three types of cartilages we're going to cover in this course: hyaline cartilage, fibrocartilage, and elastic cartilage. As you can see here, this is an example of hyaline cartilage, and this is an example of fibrocartilage, and this is an example of elastic cartilage. But I'm not going to tell you like a whole lot of detail today. Okay, just remember that we have a hyaline cartilage in the joints. Look, in the joints here, in the knee joints. We have a fibrocartilage in our vertebral column and elastic cartilage in our ear. That's what you need to know in today's lecture. I'm not going to go deeply on that. Just think about that, where you can find this cartilage. Okay, these are the some places where you can find cartilages. Okay, so what are the main characteristics of cartilage? Okay, cartilages are actually very smooth and they are flexible, and they have a thick layer. Okay, so they are smooth, flexible with thick layer. But remember that cartilages are weaker than bone and the more flexible than bones. Remember, cartilages are weaker than bone. They are not tough like bones, but that's why they are more flexible. Okay, so they are not like tough or very hard like bones. They are usually they are like they are weaker than the bones. Okay, and they are avascular. What does that mean? They do not have blood supply. Okay, then how they got nourished themselves? Okay, I'll tell you that in short moment. They do lack nerve fibers. Okay, they do lack nerve fibers, and their main function is to reduce friction, and loads and shock absorbers. Okay, they actually, if you have a stress, they absorb that stress, that shock. Okay, and these cartilages are the framework for the body, and they protect the underlying tissues. Okay, whatever the tissues that underlies the cartilages, those are protected by this type of cartilages. Okay, those are the some characteristics. If you want to go in more detail, I'll go in detail also. But the one thing that you need to understand here is cartilages are avascular and they lack nerve fibers. That's why they have a ground substances like large amount of gags. Okay, as you know what gags does, in previous lecture I mentioned you that gags are basically a glycosaminoglycans. Okay, glycosaminoglycans, and what are they look like is they are a viscous gel like structure, and they are highly hydrated. Okay, and they promote the diffusion of small molecules through connective tissue. So they do lack those vessels like arteries, right, from where they can get like those nutrients. They do lack those things. So the another mechanism they do like transport those molecules or nutrients is by diffusion, and these gags, these ground substances, help on that. And another thing what you can find in cartilages is called hyaluronic acid, and I'll tell you that function in when I'm going to talk about like individual types of cartilages. Okay, just think about that. Okay, now let's go into another slide. These are the terms you're gonna face while you're talking about cartilages. Okay, these are the terms. Okay, we just want to see what are the terms here, and we just trying to see what they do. Okay, so basically when you see these things, these are the terms related with cartilage. The first one is called perichondrium. What is perichondrium? Perichondrium is basically a layer of dense irregular connective tissue. It is a layer of dense irregular connective tissue. Okay, and what about chondroblast? Chondroblast, basically these are the cells from where chondrocytes arise. Okay, so that's what it is. Chondrocytes are basically a mature cells. Chondroblasts are the immature cells, like they are the new cells. Okay, and the lacunae, lacunae are basically, these are the areas, these are the small pits, I want to say, okay, where you can find these cells. Okay, these chondrocytes are in lacunae. Okay, and these gags, chondroitin and hyaluronic acid, these are the ground substances. I mentioned you already about this one. And I mentioned you that the cartilages, basically they're nourished by long distance, long range diffusion from nearby capillaries in perichondrium, and they have a gags, they help in that particular cases. Okay, so that's about that one. And in next lecture we're going to talk about hyaline cartilage. Before I end my today's lecture, I want to give you like a little bit more info about cartilages that might be helpful in your career, right? So let's see. So the take-home message for today's lecture, the first I'm going to talk about is the embryogenesis, the development of cartilage. The development of cartilage, the formation of cartilage is called chondrogenesis. Genesis is a term. Okay, so it's a suffix. Chondrogenesis means the formation of cartilage. Okay, and it forms from a condensed mesenchyme tissue. So it forms from where? Condensed mesenchyme tissue. This is a mesenchyme. You might heard before also, mesenchyme tissue. Okay, from where these cartilage arise. So cells of cartilage, basically like chondrocytes, usually they divide very slowly. Okay, so the growth is usually slow and steady. And the deposition of that matrix takes longer time. So that's why cartilage replacement is not usually possible, right? I don't want to say not possible, but it is difficult. So you cannot wait that cartilage is gonna reform or reoriginate or whatever. It's gonna repair itself, but you need to think about it. You have to do something from outside. So that's why in most of the joint cases, if your cartilage is teared, then what surgeons do is they do joint replacement. Okay, that's the ultimate choice, because cartilage grows very slowly and they do not have direct blood supply. That's what it is. So if we talk about repair, right, the repair system of cartilage is not really good. Why I said that, you might ask me. So the answer is chondrocytes are bound in lacunae. Lacunae are basically, what are those? These are the small pits where you have those chondrocytes, and these chondrocytes cannot migrate to the area where the cartilage is like damaged, right? So think about like platelets and think about clotting factors. They migrate from one place to the another place. Okay, they migrate from here to this place. Okay, this migration allows that wound to heal. But in the case of damaged cartilage, these are in the lacunae, so they cannot travel, they cannot migrate. Okay, so that's why it is very difficult to have the cartilage repair. Okay, and the clinical significance of cartilage, that kind of topic I'll discuss in a separate lecture. Okay, what are the disease that can be associated with cartilages, and those things I'm going to cover after I cover like individual type of cartilages. Okay, but for next lecture we'll definitely cover hyaline cartilage. We'll describe it, we'll look the structure of it, we'll find functions and locations, okay, where we can find this hyaline cartilage. And this is the most important cartilage, remember that. Okay, this is also very one of the most important cartilage in human body. Okay, thank you for watching. I'm going to see you in my next lecture with hyaline cartilage. Take care. Bye bye.
Please subscribe to see more videos regarding anatomy and physiology.